Imagine programming your robot to drive in a perfect square. You'd write, move forward, turn left, move forward, turn left, move forward, turn left, move forward, turn left. That's a lot of typing. What if you wanted the robot to do this 100 times? You'd be typing all day. This is where loops come to the rescue. They're like a robot's cheat code for repetition. Think of loops as your robot's personal DJ with a playlist on repeat. Instead of telling your robot every single step over and over, you just say, do this dance move 4 times, and boom, perfect square. Loops are programming instructions that make robots repeat actions without repeating code. There are different types of loops, each with their own superpower. Count-controlled loops are like setting a timer. Do this exactly 5 times, no matter what. Condition-controlled loops are smarter. They say, keep doing this until something changes. It's like telling your robot, keep looking for a red ball until you find one. Here's where loops get amazing in the robot world. Factory robots use loops to build thousands of cars with perfect precision every day. Your robot vacuum uses loops to continuously scan while cleaning, repeating movements until every corner is spotless. Automated lawnmowers use loops to monitor their position until your entire yard looks perfect. The coolest part? Loops make robots seem incredibly smart when they're following simple instructions. You program a loop that says, while moving forward, if you see an obstacle, turn right and keep going. Suddenly, your robot appears to intelligently navigate around furniture, but it's really just following one simple loop. Here's a real example. Want your robot to find all red blocks in a room? Without loops, you'd program every location. Check corner 1, check corner 2, and so on. With loops, you simply write, keep moving and scanning until you've found all red blocks. The robot handles the rest. But loops come with a hilarious warning. They can create epic robot fails. Ever seen a robot get stuck doing the same thing over and over? That's an infinite loop. Imagine programming your robot to spin until it finds a cookie, but forgetting to put a cookie in the room. Hours later, your poor robot is still spinning, dizzy but determined. That's why smart programmers include escape routes. We add safety checks like stop after 10 minutes or stop if battery gets low. It's like giving your robot common sense so it doesn't get trapped in its own enthusiasm. Mastering loops unlocks your robot's true potential. Want your robot to dance? Use loops to repeat moves. Want it to explore endlessly? Loops let it wander while avoiding obstacles. Want it to play games? Loops help it react to players over and over. Every incredible robot behavior you've seen, from Mars rovers exploring for months to robot dogs doing backflips, relies on clever loops running behind the scenes. These machines seem magical, but they're really following well-designed repetitive instructions.